This video is meant as further instruction just before doing the first quantitative force diagrams to analyze forces and solve for unknowns. And it involves either forces that are not at an angle or forces that occur at an angle. There are three keys to remember when doing these types of problems. The first is to realize these are equilibrium situations, which means the objects are traveling at a constant velocity or they're at rest, which means the velocity is zero, and that is a special case of constant velocity. Constant velocity means all the forces balance, and if the force is balanced, that means on the horizontal axes, the sum of the forces will be zero, and on the vertical axes, the sum of the forces will be zero. And I should say the x and y axes because we may rotate our axes, and they may not be vertical and horizontal, but we will refer to them as x and y. The second key is to break angled forces into components. So if you have an angled force vector and we had horizontal x-axis, we would want to calculate the x component as well as the y component. And you're going to want to use the trig that we practiced to do that. The final key is the net force equations. For example, let's say we had an object that had a gravitational force downward of 100 newtons, and it was on a level surface, and the force diagram looked like this. It was at rest, it was in equilibrium, and I wanted to calculate the normal force. And let's say it wasn't quick enough to realize the normal force would just be 100 newtons up. I'll show you how the net force equations can allow you to prove what the normal force is. You need to write net force equations for x and y axis. In this case, there is no horizontal forces. The sum of the forces horizontally, it's a trivial statement, is that it's zero since there are no forces. But there is a significant net force equation vertically, and the sum of the forces in y, I'll write it with symbols first, is equal to the gravitational force down plus the normal force. So that is a net force equation for the vertical forces. And I'm going to put in what I know. And I know that since this object is in equilibrium, I know that the sum of the forces is zero. I know from other information that the gravitational force is 100 newtons and it's downward, so I'm going to put a negative sign there. And I'm going to add to it the normal force, which I'm claiming I don't know. So now the net force equation reveals just one item that's unknown, and we can use algebra to solve for it. And I think you can see there, if we bring 100 newtons to the other side, that the normal force is equal to a positive 100 newtons. So the net force equations are the framework in which you will solve for an unknown. And you can see that this idea shows up here, and that the net force equals zero when an object is in equilibrium. That's important. And then when you break angled forces into their components, you may find that their components end up in that equation, and you can solve for those components or use those components, if you know them, to solve for something else you don't know.